In part 2 of our calculus explorations, a bit of a historical episode starting with Zeno. In honor of American Thanksgiving today, here's a short post. Often early in the study of calculus, you'll see these examples. It's the paradoxes of Zeno. We're going to look at just 2 of the 4, and then adjust the second to prepare for limits. The first one we'll talk about is Achilles and the tortoise, but again, because it's Thanksgiving today, we'll do Achilles and the turkey. So imagine we're going to run a race, and one of the contestants is Achilles, and the other is our turkey. Now, this wouldn't be a fair race. Achilles is much faster than the turkey, so let's give the turkey a head start. The race begins, and the first step is Achilles catches up to where the turkey began. But that took some time, so the turkey is no longer there. The turkey has run a little bit further ahead. And so as we continue the race, the next step will be for Achilles to get where the turkey is now. But again, by the time Achilles catches up to where the turkey was at that moment, the turkey has moved ahead just a little bit. And this continues, and that's our paradox. The paradox is, in order for Achilles to pass the turkey, Achilles has to get to where the turkey was. But by the time Achilles gets to where the turkey was, the turkey has moved a little bit in that same time period. So the paradox is that Achilles can never catch the turkey, but of course he does. And so that's the paradox classically known as Achilles and the tortoise. Here's another paradox. This one's easier to resolve. This one is called the stadium, and we imagine a playing field, a rectangular field like American football or international football or rugby or something like that. And the turkey starts at one end of the field and has to run across to the other end of the field. And so this paradox looks like this. In order to get to the other side of the field, the turkey has to run halfway. And now the turkey looks ahead and sees the other end of the field, and in order to reach the other end of the field from here, the turkey has to run halfway again. And so on. From here, the turkey looks at the end of the field and says, well, I got to get halfway from here and halfway from here. And that's the crux of this paradox. In order to get to the other end, the turkey has to travel half the distance from where they are. And this repeats over and over again. So if we follow this progression, the turkey never gets to the other end. But of course it does. So what's going on here? The problem is, in the telling of it, we go halfway, pause, then we go halfway, pause, and the times are not all equal. This time is not equal to this time, is not equal to this time, is not equal to this time. These times are not all equal because the turkey is moving at a constant speed. And actually that explains the paradox. The turkey runs right through these halfway markers throughout. To prepare for limits, let me ask the question, what if all the times are the same? Suppose it takes an hour to go each one of these segments. So it takes an hour to go a halfway. It takes a second hour to go another half of the halfway, or get to the 3/4 mark. Another hour to go another half of the halfway, and get to the 7/8 mark, and so on. The turkey will approach the far side. It's within a half of it, then a quarter of it, then an eighth of it, then so on, but it'll never reach it. This is the idea we're going to formalize next time when we look at limits.